Okay then. So in this episode, in this tutorial then, we're going to take a look at C# variables and constants. Okay, so we have looked at them very, very briefly before, just variables. We've got int and our string. We haven't gone into them into any real detail, and that's what we're going to do today. A little bit more detail, still at beginner's level though, so don't worry. So one of the first things we need to do is ask ourselves, what's a variable and what's a constant? What's the difference and what are they used for? So a variable then is basically a place in memory that gets put aside for a value to store during the lifetime of the program. This value can be pretty much, in most cases, looked at whenever we want or changed whenever we want during the runtime of the program. The runtime being when the program's actually running. A constant, however, is a value that we know at compile time, and that's when the program's actually being built, and it can't be changed throughout the lifespan of the program. So it's called an immutable value. So this is something that once you've set, unless you actually go back to your source code and change it and then recompile it, that value can never change. Okay, so just to quickly summarize that then, variable, a place in memory, imagine a box that we put to one side that we can store whatever we want in based off the rules that the data type sets that we'll look at in a second, and then we can look at it whenever we want. A constant, however, it's set at the start. You can read it whenever you want, but you cannot change the actual value. Okay? So why would we use a constant at all? Why would we limit ourselves to what's basically a variable that we can't change? Why would we even do that? It can add program stability and security. Okay, so that's pretty much the main reason for it. When you're dealing with things such as mathematical values, like pi, which has got a set constant value and you'd never want to change, you could store that in a constant. That way, all of your calculations and things like that will not be, changed, won't go wrong. Because if you were to change pi, your calculations would be incorrect, your program may crash, that type of stuff. So there is reasons to use a constant, and it's whenever you don't want a value to change, and it comes in handy when you're dealing with set mathematical values such as pi. Okay? So there is a reason for it, and we will use them in some of our programs. So you heard me mention earlier data types. That's sort of a new key phrase that we haven't actually used yet. We have used data types in our earlier programs when you declared an integer or you declared a string. They're data types, but we haven't actually looked into them. So data types and identifiers, basically the data type will define the rules that variable must follow. So when you say a variable is an integer, it now can't store words. It can only store whole numbers, that type of stuff. So it basically gives us the protocols and rules we must follow once we've defined what the data type is for that variable. All variables and constants must have a data type and an identifier, bar something we're going to talk about in a minute. But for the most part then, let's look at this example. So in this example then, we have string, which is our data type. We have name, which is something we set and could have called it whatever we wanted, which is the identifier, which is used to call the variable or reassign it later on. We've then got the value, because we've immediately initialized this variable. Okay? A constant is declared pretty much the same, except with the keyword const in front of the declaration of the data type. Okay? Now, the main difference between the variable and the const, other than the fact that you use the const keyword, is you must immediately initialize a const. So that's what we've done here, where we put name equals Watchitlearnit. That's basically initializing it immediately. In a variable, we could have had the semicolon after the word name, after the identifier, and later on declared what name's value actually was. But a const must be immediately initialized. So that's one of the key differences between them, other than the fact that a const cannot be changed throughout the program's life. Okay. We've mentioned data types, and now you kind of know that a data type defines what that variable can store, but what are data types? So what's available? So here is a table of some primitive data types for handling numbers. There are more than this. These are just some of the basic examples. So you've got yourself byte, short, int, and long, which are common when you're working with numbers. And then you can see the range, so such as byte has 0 to 255, and int goes from -2 billion up to +2 billion. And then we've got an example of how they're used. So we've got our byte, which is our data type, then name, which is our identifier, and then we've immediately initialized it with the value 10. So you might be thinking, kind of like the const, why would I limit myself? Why would I pick byte and limit myself to 0 to 255? No minus numbers, bear in mind, with byte. When I could use int and I have -2 billion up to +2 billion. Why would I use long, which has got an insane value, minus and plus? It's to do with memory management. As soon as you declare an int, you actually set aside enough memory, even if you're only storing the number 1, to store the number 2 billion or minus 2 billion. So if you're trying to be conscious of the memory your program's using and you know what your values are going to be, you might select something like byte. If you know it's never going to go into minus, it's never going to be higher than 255, why take up a bigger chunk of memory? You might as well take up a smaller chunk. So it's to do with memory management and basically, do you need a minus value or not, that type of stuff. Note that with long, there's also a suffix of a capital L at the end of the value, so it gets treated as a long, not as an integer when it's sub 2 billion. So that's just something to know about and something to get used to. And in this next table, there's a few extra primitive data types that we haven't looked at, such as float, double and decimal, and bool. Float, double and decimal give us different ranges of point fractional numbers, so 1.2, unlike byte, short, int, and long, which are whole numbers only. I'm not going to go into too much detail. We're going to talk about them in a later, more advanced lesson. But as long as you know for now that some of them are suffixed with letters, which we'll talk about in actual lessons when we're using them, and that if we need non-whole numbers, we need to use something like a float, a double, or a decimal. Also on that table is Boolean, bool, which is for true or false. That's all it can hold, the value true or the value false, and it's good for your statements of testing if something is true or false, or if you want to use it in an if statement, that type of stuff. And we will be messing with the Boolean a bit later on. Okay, so this is a very quick, brief overview of some data types. Now, you'll notice that there's a data type we've used that's not on here, which is string, which is for handling words and sentences. That is not a primitive data type. That is a non-primitive data type, with other things such as arrays and classes that we're going to talk about in a later episode. Okay? Now, I did state earlier that all variables and constants need to have a data type. Now, this is where I go slightly against exactly what I've just said, which is the var keyword. And the var keyword is different to the other data type keywords, as in it doesn't need a data type. Okay, so what happens with var is the compiler actually tries to figure out, based off the value it's passed, what data type to use. Okay, so here's an example where we've got var name, var num, and var dub, and name, num, and dub are just identifiers I made up. We could have called them anything. And as you can see, at one point I pass name a string, I pass it a number, and I pass it a fractional number. The compiler will then work out that name is actually a string, num is actually probably an integer, and double is probably a double. Okay? So the compiler will do some of the work. Now, I find it's better practice, personally, to declare your data types and do your variables with a full declaration. You can use var, but just so I always know exactly what data type I'm working with, it's pretty much good practice to declare your variables with a full declaration. Okay? So what we're going to do now then, we're just going to jump into Visual Studio if you fire it up, and then we'll basically mess about with some of these different variable types and do some comment and stuff, just so you've actually had a practice at it. Right, so all we're going to do here is apply the absolute basics of what we've just talked about as a bit of a recap. Okay, so I've started a console application. So remember, new project, Visual C#, console application, and I've called it example var. So remember, in our previous lessons, we stated that the static void main is where our program starts. So I've slapped a little comment in, just say it starts here, and that's where we're going to start. So in previous lessons, we've usually declared a string to store someone's name and an integer to store someone's age. We'll do the same now, just as a bit of a recap, but what we are going to do is we're going to make them constants instead. Okay, so if you remember from what I've just said, the constants start with the keyword const. Okay, then our data type, which in this case we'll do string for name, and we'll give it the identifier name. Now, if I was to put a semicolon here, like we did in our previous programs, and later on try and declare what name is, we're going to have an error. But we'll do age as well, and I'll explain the error. So constant, int, age, semicolon. Okay? So the issue here is the fact that a constant must be immediately initialized. So we've got to do our assigning operator, and then we need to do our value. I'll just put 20, why not? Okay, so now we've set them, and that's absolutely fine. But because this is a constant, one of those rules are, at compile time, these are locked. Okay, so basically right now I cannot do age equals 30 to reset the age because it's a constant. It can only be set the once, it can only be read from then onwards. Okay, so if I wanted to change that age, I would have to change it at the one time when it's declared at the top. So if I was to change this though to a normal variable, I can now get rid of the immediate initialization and initialize it later on with a new value. Okay, so that's basically the gist of variables and constants in an absolute tiny nutshell. What we will do is take another look at something else. Earlier, we mentioned bytes as an alternative to integer. So if we use the keyword byte, we'll give it the identifier b, and then we'll initialize it with the number 255. That's fine. That would output that number if we were to put it to console write line. However, if you remember correctly, byte was limited from +0 all the way to 255. So I cannot use 256 as a value in byte because it does not fit. So you need to make sure when you declare a data type that you then follow the rules of that data type. Now, something we're going to look at later on in the next video, which is overflow and then type conversion. That's where it can get a little bit trickier, where we can change bytes into integers and that type of stuff, or we can do something called overflow, which is where we run checks for if we've gone over a data type's permitted value limit. Okay, so that was just a very brief introduction into variables, just so you've got some of the keywords in there. Like you've got constant, which is new. You should now know what a data type is. You should be able to rattle off the names of different types of data types and in some cases what they can contain. You now know what I mean if I was to say an identifier. You know I'm talking about whatever we've called that particular variable. And we now know that initialization is when we set the value, whether it's immediately done or we can do it later on, as long as it's not a constant, because a constant needs to be set at compile time. Okay, so hopefully this has helped. We will look into all of this in much more detail, including arrays and classes and enums, which are also non-primitive data types, in a later video. In the next video, we're going to look at overflow and possibly also type conversion in the same video. Depends how that pans out. Until next time then, thank you very much.